Figured I would go over this again while it's still fresh in my mind. So we have this problem here. A plane flying horizontally at an altitude of 1 mile and a speed of 500 miles an hour passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when the plane is 2 miles away from the station. So obviously a related rates problem here. A bunch of variables being given, and we need to find how they relate to each other, of course, and solve for whatever we're being asked for. So what I like to do is when I get the problem, I just write down all the given values. We have altitude of 1 mile. We have speed of 500 miles an hour. And then we have distance of 2 miles from the plane to the radar station, right? And then next, I like to just, and then of course, we also want to do, let's see. So we're trying to find the distance from the plane, the rate at which the distance from the plane to the station is increasing, right? So we want dist respect to time, right? We don't know that one. So we'll just try to envision this. This is what I like to do first as well. So the plane is just starting 1 mile up above the station, right? And then it's moving this way at 500 miles an hour. Moving this way, and then the problem wants us to find how fast that the plane is moving away when it's 2 miles away. And because it's just saying the distance, it's not giving us a full vector, a way to describe the direction as well. It's not saying like it's 5 miles away east from the station, right? We just have to assume it's a straight line. So that is just going to be a straight line from P2. Say this is P1, this is P2. So this is the plane's second position. We're asked to find when it's 2 miles away. And then we'll get rid of this. And I'm going to mark this. Obviously, you can see that this is a right triangle problem. So this is going to involve the Pythagorean theorem. We're going to need x squared plus y squared equals L squared, right? So in this case, what's going to be our xy and our L, right? Well, the hypotenuse is going to be our L. Save this. Let's get rid of the units for now. This because we're in equal space. This is our L. This is 1, right? Because we know that the altitude is 1. So this can be our x. I'll just call that x. And we'll say this is our y, but do we know the y yet? It doesn't look like we've been given the actual horizontal distance here that the plane traveled across, right? We just know the straight line distance, which is the hypotenuse. So we're going to need to find that. How do we find that? Well, again, Pythagorean theorem. And do that equals L squared. Then we plug everything in. So 1 squared plus y squared equals 2 squared. And then obviously 1 squared is just 1 plus y squared equals 4. Then we want to solve for y, so we'll get rid of the 1 over there. That leaves us with y squared equals 3. Then, of course, we just square root both sides, right? And that leaves us with y equals square root of 3. So now we can go back. Then we can put a square root of 3 over here. I'll get rid of all of this to clear that up. And then next, what I would like to do, what I usually like to do is just kind of mark everything just for my own bookkeeping. I just like to mark what in here is constant, what's not constant. Well, the altitude is going to be constant, right? It's not going to be changing. From what we can see here, we just are giving a strict altitude of 1 mile. We know that this is going to be changing because it's going 500 miles horizontally, right? 100 miles an hour. So this is not constant. We also know that this is not constant because we're being asked to find the rate at which the plane is getting further away from along this vector here, right? So we know that there's two variables that are going to be changing with respect to time. We can find these as yt and lt, but there is no xt. So we also know that, so we can say right away that when we differentiate the Pythagorean theorem here, because this is the constraint equation that we need, right? Because it's a right triangle. When we differentiate this, you're not going to be differentiating x squared, right? So let's go ahead and differentiate. So we'll differentiate everything with respect to time. Oops. Y squared d over dt L squared. Right? Again, we said we weren't going to differentiate this because it's constant, and anything differentiated by a constant is, of course, just a big old fat 0. Then we differentiate this. Y squared is just 2y, and then differentiate it with respect to time, so we have to multiply that by the excuse me, rate at which it changes with respect to time. And then this obviously would just be 2L times dl over dt, right? And now it's as simple as just plugging everything in, right? Because we already found all these values here. So we know that 2y, what's our y? Our y is also, I like to actually, let me just for bookkeeping sake, I like to, where can I put it? Right here, right? X equals 1, y equals square root of 3, L equals 2. I just like to put those in so I can quickly look and plug them in. So we know 2y is just going to be 2 times square root of 3. And then what's the rate for y? Again, that was our speed of 500 miles an hour. So we just plug in the 500. And then on this side, 2 times L. What's L? L is just 2 times dl t, which is what we're trying to solve for, right? So now we're just solving for dl of dt. So 2 times square root of 3. Just going to do the 2 times the 500 just to make things easy. And that'll be 1,000 times square root of 3. And then over here, we just have 2 times 2 is 4 times dl of dt. Well, again, we want to isolate the dl of dt because we're solving for dl of dt. So divide both sides by 4. 1,000 divided by 4 is 250. Square root of 3 dl of dt. And we are done. So this is going to be our final problem. So we want to represent this, of course, with the units measurement. I think it's going to be miles an hour, right? And so that's how you solve a problem like this. It's really just as simple as kind of get all the values that you can from the problem. I like to, this is optional right here, drawing. I just like to do it because it really helps you visualize everything and kind of serve as redundancy. Then you want to figure out what's constant, what's not constant, write that down so that you know. And then, of course, once you have the constraint equation figured out, whether it's red triangle, sphere, volume, surface area, area of rectangle, you know, whatever it is, just simply differentiate it pretty easily. Again, if one of them is constant, then you're not able to differentiate it, so it's just going to cancel out, be a big fat 0. Just do very simple differentiation right here, and then you're just plugging in values. And it is as simple as that. So, hope this helped. Thank you very much for watching.